We're going to talk about what's called the commutative and associative laws in algebra. Let's just have a look at what they say straight up, and then we'll look at two examples. So hopefully pretty straightforward. The commutative law just says that a plus b equals b plus a, and that a multiplied by b equals b multiplied by a. So you can see that addition and multiplication are what are called commutative operations. If we look at the associative law, it says that a plus b plus c is equal to a plus b plus c. And a multiplied by b multiplied by c is the same thing as a multiplied by b multiplied by c. So you can just see that the brackets have been shifted around there. Let's have a look at some examples of what's going on here. We can extend this to three variables as well. So if we consider the line c, a, and b, by the commutative property, c plus a plus b is the same thing as b plus a plus c. Because the key is in the term commute. Commute means to move around. So those terms can move around and you don't lose the overall meaning. The meaning stays the same, right? Or the value or the result stays the same. So we can see that that's an example of the commutative law. The associative law can also be explained through this little diagram here. If we do C plus A, we add those together first and then add B. That's the same thing as adding C plus A plus B. So that's an example of the associative law. Another diagram we got going on here is just another example of the commutative law. If we've got a rectangle with side length x and y, you would agree that the area of this rectangle is x multiplied by y. In algebra, we write that as xy. And that is whatever it is. If we swap those around and make the longer side y now, and the shorter side x, well, we still get y times x, and we get yx, xy, same thing because of the commutative property of multiplication. So when you multiply or when you add, you can do it in any order. Let's have a look at a problem. And we'll talk about this one together. So the problem says g plus 3m plus something equals 2k plus something plus g. Evaluate the somethings, right? Well, let's just look here. So we can see that on the left-hand side, we've got a 3m. So that must mean somewhere on the right-hand side, we have to have a 3m if the expressions are equivalent. So g plus 3m plus 2k equals 2k plus 3m plus g. So you can see that we've just shifted those brackets around, and it doesn't matter the order in which we do things. 3m plus 2k is obviously the same thing as 2k plus 3m. So we can, apply some of these laws. So hopefully you can see how that checks out as the correct answer. Try this one out to see that you fully understand it. So the problem is 4n plus p plus something equals p plus something plus 2k. Let me know what you think. Good luck.